Okay, this is section 5.1 continued. We're going to continue on with example 4, part B. We had just found that 10(1) is a solution for x minus 3y in the last video. We'd found that I'd made a mistake by adding the opposite of this side, but I hadn't over here. And when we looked to see if it satisfied the equation, we found that it didn't. And now we should say, okay, is this going to be true, right? 10 minus 3 times 1, which is 3, is that equal to 7? Bingo, now we do have that solution. Now remember, this isn't the only solution. There are an infinite number of solutions. All right, our next task is to do the second problem down here. So again, I can choose to plug in for the x or the y. It's totally up to us. However, it's easier to plug in for the y's in this equation as well, because the numeric coefficient of x, even though it isn't a 1, it's a 2. And finding numbers that easily divide by 2 is much easier than finding numbers that easily divide by 5. So I'm again going to choose to plug in for y. So I'm going to let y equal, and I'm going to let it equal some odd number, because multiplying this by an odd number is going to say an odd minus an odd, which is going to give me an even number, which will be divisible by 2. Now, all of that I just talked about there is just extra fluffy information. That extra fluffy information can make us have nice integer ordered pairs, which is really helpful with our next task, which is to find a solution on a graph of this by plotting the ordered pairs that we're finding as solutions. So I'm going to let y, I'm going to let it equal, let's say 3. So 2 times x plus 5 times y, which is equal to 3, I substituted in, is equal to 9. So 3 times 5 is 15, so that's a plus 15, so I'm going to add the opposite of 15 to both sides so that I can solve this equation for x. You see, I'm just solving a linear equation in one variable now, because the other variables have gone away because I substituted in for it. So 2x is equal to 15 subtract 9, which is 6, and it's a negative because the 15 is larger. And then I'm going to multiply by the numeric coefficient of 2, which looks like division because it is, and then I get my value of x. X is equal to a negative 3. And finally, I have my x, which is negative 3, and my y, which was positive 3, and I put those into an ordered pair. And then I want to see if it does satisfy. Negative 3 times 2, which is negative 6, plus 3 times 5, which is 15. 15 minus 6, does that equal 9? Absolutely. So we have a check there. Moving on to my next one. Now you see that neither of the numeric coefficients are wonderful here. So we're just going to go ahead and plug in for one and see what happens. So I'm just going to say, okay, let's let x equal, and let's try x equals, I don't know, negative 2. So 3 times negative 2 minus 7y is equal to 9. And then we are solving for y this time around. So we're going to simplify this. 3 times a negative 2, which is a negative 6, and that minus 7y is equal to 9. So we're going to add the opposite of 6 to both sides, right? Adding 6 to both sides. And that's going to give us that 0 minus 7y, so I'm just writing minus 7y, is equal to 9 plus 6, which is 15. And then I'm going to multiply by the reciprocal of the numeric coefficient, negative 7, and that's going to give me my answer. So what I get here is that y is equal to a negative 15 sevenths. Now, because it's an ordered pair, I'm going to leave it as an improper. But you know, to graph that, we'd need a mixed number. And then finally, we have x is equal to negative 2, and y is equal to negative 15 sevenths. And what you notice is this isn't an integer ordered pair. If I were to have to graph that, that would be a really big pain. So one of the things that's so convenient about slope-intercept form is that it's much easier to find those integer ordered pairs. All right, I'll see you.